How you doing? Today we are going to look at chapters 1 through 3 in water reuse. Just an introduction to the course. In Ohio, we are where I'm from, and I would assume most of you are. I know it's an online course. We don't have a lot of water reuse. But in states like California and Florida, it is in other arid regions, water reuse is becoming a huge issue for water operators because of those arid climates. They just do not have the resources that we have. Their aquifers may need replenished. They're experiencing population growth, and so really, uh, us as administration, we thought this topic would be good for you to study. So when we talk about the context of water reuse, and we want to talk about sustainability. So sustainability is the principle of optimizing the benefits of a present system without diminishing the capacity for similar benefits in the future. One thing we want to make sure is that we're not using a resource up for future generations. And so, if we can take water and reuse it for a beneficial use, obviously we are conserving on a needed part of society that will be needed in the future. And so, we want to be able to sustain our water supply. We don't want to take too much water out of our aquifers that we have. Another question is what constrains the feasibility and reliability of providing adequate water to society? Geography, we've talked about that. Um, Florida, California, some of those arid states, just from where they are in their weather, they do not have um, the accessibility to the water supplies that people in the Midwest do. Hydraulic, once again, just where are you getting your water from? Economic, so how expensive is it to take that water and make it usable? You think about a cruise ship, right? They need to get their water from somewhere, and so they can have fresh water supply, but they can also perhaps have a desalination plant on board. But how expensive is that, right? Like how doable is it to make water reusable? And so as we talk about this topic, you're constantly battling those things. Um, can we keep it sustainable? And then how much is it going to cost us to reuse water, right? And is it safe for the general population to be using this water? Social factors. There, um, you know, people want to drink wastewater, and when we talk about wastewater is direct reuse. Like if we pump it straight out of uh, the wastewater plant back into the water plant, and it's just doing a circle, and we're adding a little bit to that, there's like a ick factor there, right? Even me just talking about it probably gives you some sort of ick factor. I know in Nambia, overseas, they've piloted a program where it is direct uh, reuse. But here in the States, we don't really have that. What we have is de facto use, and that's one of your questions, where we'll take wastewater and we will pump it into aquifers, and then it will replenish the aquifer, and then you kind of take it back out. Or de facto uses, we may put it into a river, and then a city south of us will take that water back out of. And so in a way, they are drinking wastewater. And so I'm also a wastewater operator. It's important that what we put out is a pure effluent, because there are cities that by de facto or indirect use are using that water again for drinking water. And so we are doing it in the States. in a direct way, um, but we have not, that I know of, we're not taking it in a constant loop. We're not taking it just from the wastewater and pumping it back to the water plant. And so you'll have that, just social factors. A lot of people don't want that. They want clean. They think it's clean if they take it just out of the wells. But what we see is population growth. Florida, California. Um, as our numbers of people increase, as we have urban sprawl, we are going to have to provide more and more water to for the increase in population. And population growth maybe will decrease in one area, but will increase in another. And so, that is one thing we need to look at when we talk about the constraints of feasibility and reliability. When it says list the criteria for sustainable water resources, you'll see that on page 9. Uh, Meet basic human needs. Every human needs water. You say, well, I don't drink water. Well, pop has water in it. Tea has water. We need to maintain the renewability of it. We need to encourage water conservation in our public water systems. Um, we need to design it that it is able to adapt, and we need to preserve the ecosystem. We don't want to use water or have water reuse that puts um, a negative consequence to our environment. So if we are draining a marshland, or we're putting in maybe our effluent from our concentrate line at the water plant, if it's somehow harming the ecosystem because it's too warm or the pH is wrong, we don't want that. We want it, very sustainable. Um, and yeah, so going to question 4. It says, why is water reclaimed and reused? Because water is a limited resource, right? Like, it's only limited to a certain amount here on the earth, and we need to take care of it. We need to conserve fresh water supply. So that on page 12, you can see some of those benefits. Page 5, let's turn over to page 24 in the book. So it says, what are the potential uses of reclaimed water? So you can see agricultural irrigation, for farmers' fields, landscape irrigation, which is a common, golf courses, industrial recycling reuse, maybe a factory uses water for their cooling system. Maybe they can recycle that and reuse it. Groundwater recharge, like I said, we're doing that in some of those arid climates. We're already taking the water, injecting it back into the aquifer so that we can recharge it. Fire protection, having a reuse for just fire protection, toilet flushing. You see that kind of in high-rise buildings, blending water supply reservoirs, and then the final is direct pipe to a water supply. So those are the potential benefits. Uh, Describe integrated water resource planning. It's the process that promotes the coordinated development and management of water, land, and related resources to the maximum, resultant economic and social welfare in an equitable and sustainable manner. Once again, we are just trying to um, we're just trying to be good stewards of it. Verse Question 7, what are the new responsibilities? As water operators, we need to know the economics, We need to be a steward of it, and we need to make sure that we're meeting future needs. Hurdles for implementation. Sorry. Uh, that is on page 81. So when we talk about hurdles, one is finances. Not even looking at that. One I've already mentioned is the ick factor. Maybe some people don't want, um, you know, they don't want. I'm sorry. I think that is page third. Yeah, public support. Um, you know, advances in water reclamation technology. It takes, sometimes it may take technology that is highly developed, and we're still learning every day. Some people might be okay with using uh, reused water to flush toilets and for fire hydrant protection, but not um, being used for drinking water or using on special agricultural uh, food products. So those are some of the hurdles. When and where did the reuse begin? It basically began, one theory is it began around 3,000 years in the Crete, Greece area. And then it's in the modern area, it's really developed in California around the 1900s. That's when they really started exploring the reuse. That we've been doing it overseas also, but we are trying to. I know I visited Australia, and around the 2000s they had a great drought there, and so they tried to develop taking seawater and putting it through reverse osmosis to make adequate drinking water for Australia. And so overseas they are doing a lot with that. Um, 11. What factors contribute to water reclamation? Once again, stringent wastewater treatment, conducting water reuse demonstration projects, the development of water reclamation and reuse guidelines, rapid growth in the West, increased development in humid climates. As the West builds and as we build overseas in those arid climates, um, and as we produce crops in California and in Florida, Florida is known for its oranges. We need to be able to irrigate those with water. The Clean Water Act on 12. So if you're from Ohio, the Cuyahoga River caught on fire in the mid 1900s, and so at that point the EPA stepped in. Really, the Clean Water Act was developed. The Clean Water Act regulates what industries can put into uh, rivers and streams, but it also protects. Clean Water Act is what we work under as wastewater operators, and it protects those streams. And so, like at my plant, I can't just discharge high levels of ammonia. So the federal government uses the Clean Water Act. The Safe Drinking Water Act is actually on the public water side. And so the EPA, the Safe Drinking Water Act, is the main law to keep our drinking water safe. So both of those come into play when we talk about water reuse, um, what we're putting out in the effluent of our wastewater, and then also, is what we're using in the drinking water, is it pure for the population? Chapter question 13. It says what most water reuse sites located. Most of them are in arid and semi-arid, um, Florida, New Mexico, those California. Um, verse, or I keep saying verse. Question 14 and 15, you can read on those on page 47 and 53. Uh, Question 16 is on 58. Is water reuse. It talks about in other parts of the world, it talks about the drought in Australia, talks about um, in Namibia, and Namibia, because of extreme drought conditions, extensive research was conducted in 1968 on the direct potable reuse water technologies, and the epidemic study was conducted to assess the health effects of reclaimed water concentration. So, you know, um, overseas they are using water reuse. We talked about de facto portable reuse. Basically, by default, you're using wastewater in your drinking water. Who is responsible for detecting, monitoring, investigating waterborne diseases? And that would be your state and local health departments. So in Ohio, it would be, um, you know, it would be the EPA. 19, the list of pathogenic microorganisms that are found in wastewater. So you've got cryptosporium, hepatitis A, norovirus, rotavirus, adenovirus, salmonella. A lot of these, in the 1800s, before the development of the microscope, and they really didn't understand, um, that contaminated water, even though it may look clear and clean, contaminated water will cause these diseases. And so, Middle Ages, and even I was listening to a documentary today about people during the Revolutionary War that drank um, contaminated water, and they did not, understand that that was harmful. And that didn't really change to the late 1800s, early 1900s. 20, what are the characteristics of an indicator microorganism? I have them on my phone here. Let me get to 19. An indicator must be present when fecal contamination is present. The number of indicators organisms present should be equal or greater than the target pathogen. The indicator organism must exhibit the same or greater survival characteristics in the treatment process. Um the indicator organism must not reproduce outside of the host. So, and there's a couple others. The organism should be a member of the intestinal microflora of water, blooded animals. So, at my wastewater treatment plant, we treat the wastewater, and then before it goes out to the creek, it hits the UV, and in that ultraviolet light that disinfects the uh, wastewater, and we grab what we call an E. coli sample. And so we take that E. coli, uh, we incubate it, we run it through, we add some a broth, and then we incubate it, and then we count the E. coli numbers, and that gives us good representation of an indicator of how polluted um, our wastewater is. And at our wastewater plant, we do pretty well. What are the levels of treatment and treatment used to remove harmful pathogens? Hopefully you've had my wastewater class, but if you have not, we use preliminary treatment, where the wastewater comes in, we remove the rags, and then we go primary or secondary. where we might run the wastewater through an activated sludge plant, where the sludge will break down the beauty and ammonia, and then we put it into a secondary clarifier. And at that secondary clarifier, the mixed liquor will separate from the water. The water will come up to the top, and then we use a tertiary treatment, which will be another fine filtration. And then, if you're going to reuse it for drinking water, you perhaps may put it through an RO or a nano filter. Um, but that we treat our wastewater almost to the standards of where, in my mind, if I had to drink either from the creek or from my wastewater tap, I would drink from the wastewater tap for sure. Um, 22. So 22 is how do chemical constituents enter wastewater? Obviously, industrial cleaning agents will get dumped into the toilet. You may get, if you're having a combined sanitary sewer, the water that comes off of the roads, the oils and the gases will go through the sewer plant. And so, once again, there's lots of chemicals that enter into wastewater that we need to be concerned about. An emerging contaminant is one that, we are keeping an eye on. That's a new, something new that we're not. It says the term emerging contaminant is used for chemicals and microorganisms that have been identified in the water only recently and under consideration to be regulated. These are the PFAS, the chemicals that may be in our industrial use that are new, that we don't understand, and we don't really understand what they are at a low dose or a high dose and how those affect humans. So it's just a contaminant that is new. Um, how can it impact the environment, right? Soil and water in reclaimed water, such as nutrients, salts, organics, and inorganics, may affect the soil. So, like, we are adding our wastewater to a golf course. That wastewater may have salts, organic or inorganic material that may affect the grass, may affect the ecosystem around it. When we discharge, discharge to groundwaters, once again, those pathogens may get into the deep, wells that we inject in. It just a whole lot of things can contaminate. Perhaps the water is too warm, and we discharge it to the ecosystem, and the aquatic species are not used to that warm of water, and so we disrupt their habitat. I know that's a lot. Once again, I just try to make these videos to explain the homework a little bit, give you an idea of what's going on. I know they are a little rough, but try to do my best here. So thank you. I appreciate you taking my class.